Next is the product to sum identities. Remember, product means multiplication and sum means addition, so we're turning multiplication into addition. And so for instance, if I have sine u times sine v, that is going to equal 1/2 times the quantity cosine of u minus v minus cosine of u plus v. So that's what it is for sine. Then if you have cosine u cosine v, then that's going to be the exact same thing, except instead of minus, it's plus. Now we can also have a mix and match, for instance, sine u cosine v, which that's going to equal 1/2 sine u plus v plus sine u minus v, which, yes, I know this is really annoying and really easy to confuse all of these, but there's just one more. The last one is cosine u sine v, and that's going to be the exact same thing except minus sine u minus v. So again, these are called the product to sum identities when we start with multiplication and we want to end with addition or subtraction. And then the last of the identities we have is the sum to product identities. This is the exact opposite. We start with a sum, addition or subtraction, and we're going to turn it into a product multiplication. So for instance, if I have sine u plus sine v, then the formula is 2 sine u plus v over 2 times cosine of u minus v over 2. Yeah, that's a lot. But don't worry, there's 3 more. Next is cosine u plus cosine v, which is going to be 2 cosine of u plus v over 2 times cosine of u minus v over 2. And then for this one, we don't have the mix and match with sine and cosine, but we do have sine u minus sine v, which is going to be 2 cosine of u plus v over 2 times sine of u minus v over 2. And then the last one, I swear, is cosine of u minus cosine of v, which is going to be 2 sine of u plus v over 2 times sine of u minus v over 2. And if you see, we got every possible combination of sine and cosine out there. And so the last thing we're going to do today is just look at some examples of product to sum and sum to product. So for this first one, let's say I have sine of y times the sine of y squared, and I want to use the product to sum property. Well, that's easy. I'm just going to plug in the formula, which was 1/2 of cosine of u minus v. U is y, minus v is y squared, and then minus cosine of u plus v, y plus y squared. And the good news is you don't have to reduce this because these cannot be reduced. There's nothing else I can do here. This is the final answer. Here's another one for us. Cosine of 6x times sine of 4x. So I see u here is going to be 6x, v is going to be 4x. It's cosine times sine, which means I'm just going to plug in the formula I wrote down earlier. 1/2 sine of u plus v, 6x plus 4x, which I will reduce in the next step. And then minus sine of u minus v. So this time, since it's both x, I can combine these. It's going to be sine of 10x minus sine of 2x. And I'm happy with that. I can leave it like that, and we're done. And then finally, we're just going to practice a couple with the other one, the sum to product. So let's say I have sine 2x minus sine x. This is the sine u minus sine v case. So just plugging that in the formula, 2 cosine of u plus v over 2 times the sine of u minus v over 2. And this can simplify a little bit. It'll simplify to 2 cosine of 3x over 2 times the sine of just x over 2. And that's our final answer for that one. And then just one more, and we'll be done. Let's say I have cosine of 3x plus cosine of 5x. So for this one, I do want you to try it on your own. Pause the video, give it a try, and when you're ready to see the answer, unpause. So obviously this will be the cosine u plus cosine v case, which means the answer is going to be 2 cosine of u plus v over 2 times the cosine of u minus v over 2. And that's going to get me 2 cosine of 8x over 2 times cosine of negative 2x over 2, which I can reduce again to 2 cosine of 4x times cosine of negative x. And if you left it like that, I'm happy. If you also said, hey, the even function property from earlier, this is actually going to be positive cosine, and you can just ignore that negative entirely because of the even identity. And I would be very impressed if you saw that. But either way, I'm okay with both of these answers here. So that's it for this identity. If you want to watch the full video with every trig identity, that's in the description. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.